So what we have learned? We learned that regression analysis is a statistical method. We use it to examine the relationship between a dependent variable and one or more independent variables. If y equals a plus bx is our regression equation, the estimated value of b, denoted by b cap, equals n sum of xy minus sum of x sum of y divided by n sum of x square minus sum of x whole square. And the estimated value of a cap, equals y bar minus b cap x bar. The estimated value of the slope b determines the nature of relationship between the variables. If the estimated value of b, that is b cap, is positive, the relationship between x and y is positive. And if the estimated value of b cap, is negative, the relationship between x and y is negative. Now I am going to give you an example to show you how we can apply this formula. Suppose you are given data on price and quantity. Here we see when price is $10, for example, quantity is 300 units. When price is $12, quantity is 285 units. This way there are 10 pairs of price quantity data. Now the primary requirement is what kind of equation can you estimate from the given data. Here you see we are given the price and quantity data, and we know price quantity relationship is either exhibited by a demand equation or by a supply equation. So we can either get a demand equation or a supply equation. First of all, we shall try to understand whether we shall get a demand equation or supply equation for visual inspection. That is, we shall examine the movement in the variables. In figure you see, if price rises from $10 to $12, quantity falls from 300 units to 285 units. That is, it exhibits a negative relationship between price and quantity, which is true for demand equation. Again, if price rises from $12 to $15, quantity rises from 285 units to 290 units. This time it shows positive relationship between price and quantity, which is true for supply equation. Similarly, if price rises from $15 to $18, quantity falls from 290 units to 255 units. Clearly, the relationship between price and quantity is negative, which is true for demand equation. This way, if we move down, we find that for most cases, the relationship between price and quantity is inverse. That is, we find that for most cases, law of demand works. That is why we can expect to have a demand equation from the given data. Now the question is, how can we estimate the desired equation? As I have mentioned, for most of the cases we find there exists an inverse relationship between price and quantity, and hence we can estimate a demand equation from the given data. Let us now set a regression equation to estimate the demand equation. It can be given as Q equals A plus BP. Here the estimated value of B, denoted by B cap, equals n sum of PQ minus sum of P sum of Q divided by n sum of P square minus sum of P whole square. Now we have to extend the table according to our need to find the value of B cap. You see here there are a total of 10 pairs of data, so n equals 10. Now we have to find out PQ. In table, multiplying P by Q, we can get it. For example, for the first pair of data, PQ equals 300 multiplied by 10 equals 3000. Similarly, for the second pair of data, PQ equals 285 multiplied by 12 equals 3420. This way we can find out the other values of PQ. Summing up the values of P, we can get sum of P. Similarly, summing up the values of Q, we can get sum of Q. In the denominator, there is P square. In table, we can easily get the P square. Here P square equals 100 is found as squaring P equals 10. Similarly, 12 square equals 144, 15 square equals 225, and so forth. Once the table is constructed, we can easily get the sum. Here, sum of P equals 237. Sum of Q equals 2190. Sum of PQ equals 46,270 and P square equals 6,567. Now let us substitute these values in the formula of B cap. Here you see n equals 10. Sum of PQ equals 46,270 minus sum of P equals 237. Sum of Q equals 2,190, and in the denominator n is 10 multiplied by sum of p square, which is 6567, minus sum of p whole square, that is 237 whole square. After the necessary calculations, we find b cap equals minus 5.929. Now, the estimated value of a, that is a cap equals q bar minus b cap p bar. We know q bar equals sum of q divided by n. Sum of q equals 2190. If we divide it by 10, we get 219. Similarly, p bar equals sum of p divided by n means 237 divided by 10, which makes 23.7. Setting these values in a cap, we get a cap equals q bar, that is 219, minus b cap, that is minus 5.929, multiplied by p bar, that is 23.7. Hence a cap equals 359.5. Setting the estimated value of a cap and b cap in the regression equation, that is in the demand equation, we get q cap equals a cap, that is 359.5, plus b cap. Here b cap equals minus 5.929. So plus and minus makes it minus 5.929p. This is how we can estimate our desired equation using regression analysis.